Hello, in this lecture we will find out the area of a circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have this circle. In addition, we know that side AB of this quadrilateral equals to 2 units in its length. Side BC equals to 8 units. Side DC also equals to 8 units. This is angle ABC, that is equal to 90 degrees. And this angle ACD, angle DCB, is also equals to 90 degrees. Again, our mission is to find out the area of this circle. So, first of all, we will do a construction. That is to say, we'll extend side DA and side CB of this quadrilateral by a straight line until they touch each other. The extended side CB and the extended side DA touch each other here at this point. We will define their touching point as point M. We will define this angle as theta, and we will focus on the right big triangle, triangle DCM. In the right big triangle DCM, this angle equals to 90 degrees, this angle equals to theta. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. We will focus on line segment BC. Line segment BC is one side of quadrilateral ABCD. Therefore, it is absolutely a straight line. Then we extended the straight line BC by straight line, and the result is CM. When you extend a straight line by straight line, the result must be a straight line. So CM is a straight line. So if we focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees. According to the rule, then the sum of the angles on one side of a straight line is equals to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees plus the missing angle that is actually angle ABM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees in its size. In order to complete the sum of the angles on the upper side of the straight line CM at point B 280 degrees, the missing angle here must be equal to 90 degrees in its size. So angle ABM is a right angle. Therefore, triangle ABM is a right triangle. We'll focus on this the right small triangle, triangle ABM. In the right small triangle, triangle ABM, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. So I write it down. in the next step, we will prove that the right big triangle, triangle CDM, is similar to this right small triangle, triangle MBA. And again, we will prove that the right big triangle, triangle DCM, is similar to this right small triangle, triangle MBA. So I write it down. Triangle CDM is similar to the right small triangle, triangle MBA. So why those two right triangles are similar to each other? First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So actually this is angle DCM in the right big triangle DCM, and it equals to this angle that is actually angle ABM in the right small triangle, triangle MBA. Repeat again. Angle DCM in the right big triangle DCM equals to angle ABM in the right small triangle, triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so you can write down that angle theta equals to itself as a common angle that belongs to both triangles. So if we relate to this angle, angle theta, as it belongs to the right big triangle, triangle DCM, it will be called angle DMC. And it equals to itself. If we relate to angle theta as it belongs to the right small triangle, triangle MBA, it will be called angle AMB. Repeat again. This equation means that angle theta equals to itself. We just called to angle theta two different names. Angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Actually, this is angle MDC. In the right big triangle, triangle DCM, and it equals to this angle, that is actually angle MAB, in the right small triangle MBA. Repeat again. Angle MDC in the right big triangle CDM equals to angle MAB in the right small triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles of the right big triangle DCM are correspondingly equal to all the three angles of the right small triangle MBA, this right small triangle MBA. Therefore we actually proved that those two right triangles are similar to each other according to angle similarity rule. So I write it down. We prove that the right big triangle, triangle CDM, is similar, this is the sign of similar, to the right small triangle, triangle MBA, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that side DC over in the right triangle DCM over side AB in the right small triangle MBA equals to side CM in the right big triangle DCM over side BM in the right small triangle MBA. Repeat again, we conclude that DC over AB equals to DC over CM. So actually DC over AB equals to CM over BM. Repeat again. DC over AB equals to CM over BM. Repeat again. DC over AB equals to CM over BM. DC equals to 8 units in its length here. It's given us the question. Over AB equals to 2 units in its length according to what is given us the question. And it is equals to CM over BM. CM equals to CB plus BM. CB is 8 and BM is the missing side, so in total CM equals to 8 plus BM. So here we substitute CM by 8 plus BM, and we have to divide it by BM. So in conclusion, we found out that 8 over 2 equals to 8 plus BM over BM. Here 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiply this equation by BM, and we get that 4 times BM equals to 8 plus BM. So here we'll subtract BM from this equation, and we get that 4BM plus BM is 3BM. So 4BM equals to 8. Here we'll divide this equation by 3. And finally we'll get that BM equals to 8 over 3 units in its length. So this side BM equals to 8 over 3 units in its length. So I write it down in the drawing itself. BM equals to 8 over 3 units. In the next step, we will focus on the small right triangle MBA, and we will implement on this right small triangle the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sums of the squares of the perpendiculars. Again, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, the hypotenuse in this small right triangle MBA is AM, and therefore the square of the hypotenuse is AM squared. It must be equal to AB squared plus BM squared. Repeat again. According to the Pythagoras theorem, in the right triangle MBA, AM squared equals to AB squared plus BM squared. So AM squared is the square of the hypotenuse. Equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus BM squared. BM is 8 over 3, therefore BM squared is 8 over 3 squared, that is 64 over 9. So in conclusion, we found out that AM squared equals to 4 plus 64 over 9, so AM squared equals to, here we multiply 4 by 9 and then we divide it by 9 in order to make our factor with 64 over 9. So 4 times 9 is 36, so in total in the numerator we will have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. So AM squared equals to 100 over 9. Here we take a root out of this equation. And finally we get that AM equals to the square root of 100 over 9. The square root of 100 over 9 is the square root of 100, that is 10, over the square root of 9, that is 3. So total we found out that AM equals to 10 over 3 units in its length. The hypotenuse AM equals to 10 over 3 units in its length. So I write it down. The hypotenuse AM equals to 10 over 3 units in its length. In the next step, we will do another construction. That is to say, we will draw perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. Okay, again, we will draw perpendicular on BC in such a way that it will be also tangent to this circle. It is absolutely possible because we can choose any point on side BC to draw the perpendicular. Therefore, we'll choose the point in such a way that it will be also tangent to this circle. So first of all, this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular and side VC is T. We define the point of tendency of the perpendicular with this circle as point K. In the next step, we'll extend the perpendicular TK until it touches side VA. And we'll define the touching point of the extended perpendicular TK beside DA is point S. By doing this construction, we actually created here the right middle triangle, triangle MST. This is right middle triangle, triangle MST. We focus on this right middle triangle, triangle MST. In this right middle triangle MST, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. We define the center of this circle as O. We define the point of tendency of tangent BT with this circle as N. And finally, we define the point of tendency of tangent AB with this circle as L. We will define the radius of this circle as X. And we will join points O and N together by a straight line. Line segment ON is the radius of this circle because it starts from point N, that is the center of the circle, and then it starts from point O, that is the center of the circle, and ends at point N, that is the point on the circle itself. This is exactly the definition of a radius. So ON is the radius of this circle, and according to our definition, the radius of the circle equals to X. So ON equals to X units in its length, it is the radius of the circle. And we have here rule 1 that we can implement in our drawing. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. In the drawing we have a circle and we have tangent AB to this circle, that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. According to this rule 1. So actually implement rule 1 in our drawing. Why? Because in our drawing we have the radius ON that is drawn to point N, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius NO. If BT is perpendicular to NO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and K together by a straight line. O and K by a straight line. Line segment OK is the radius of this circle that is equal to X. Again, we have the radius OK that is drawn to point K. Therefore, we can implement rule 1 according to rule 1. This angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points O and L together by a straight line. Line segment OL is the radius of this circle that is equal to X. Here we can implement rule 1 because we have the radius OL that is drawn to point L, and therefore according to rule 1 this angle will be equal to 90 degrees, and this angle also equals to 90 degrees. In the next step, we will focus on this small quadrilateral. We focus on this small quadrilateral LBON. This small quadrilateral LBON, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles in this small quadrilateral LOBN to 360 degrees, the missing angle here must be equal to 90 degrees in its size. Therefore, quadrilateral LOBN has 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this small quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side LO equals to side BN. But LO equals to x, therefore BN must be also equal to x. In the next step, we will focus on this quadrilateral OK and T. This small quadrilateral OK and T, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. So quadrilateral OK and T is 4 right angles. Therefore, we can relate to this quadrilateral as a rectangle. And we also note that the opposite sides of a rectangle are equal to each other. That is to say, side OK must be equal to side NT in rectangle OK and T. But OK equals to x, therefore NT must be also equal to x. So in conclusion, we found out that the length of line segment BT is equals to x plus x, that is 2x. So I write it down. Yeah. BT equals to 2x. In the next step, we will prove that the right middle triangle MST is similar to the right small triangle NBA. So write it down. We'll prove that the right middle triangle STM is similar to the right middle triangle NBA. So why the middle triangle STM is similar to the small right triangle MBA, this small right triangle MBA. First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually this is angle STM. In the big right triangle STM, in the middle right triangle STM, and it is equals to this angle, that is actually angle ABM, the right small triangle ABM, MBA. Repeat again. angle STM in the right middle triangle STM equals to angle ABM in the right small triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so you can write down that angle theta equals to itself is a common angle that belongs to both triangles. So if we relate to this angle theta, as it is belongs to the right middle triangle STM, it will be called angle SMT. And it equals to itself. So if we relate to angle theta, as it belongs to the right small triangle MBA, it will be called angle AMB. Repeat again. This equation means that angle theta equals to itself. We just called to angle theta two different names. So angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually this is angle MST. The right middle triangle MST, and it is equals to this angle that is actually angle MAB in the right small triangle MBA. Repeat again. Angle MST in the right middle triangle STM equals to angle MAB in the right small triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the right middle triangle STM are correspondingly equal to all the three angles in the right small triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. The right middle triangle STM is similar, again this is the sign of similar, to the right middle triangle MBA according to angle similarity rule. And from the fact that the right middle triangle is similar to the right small triangle, we will derive that the following relationship exists between their sides. We will derive that side ST in the right middle triangle STM over side AB in the right small triangle MBA is equals to side TM in the right middle triangle STM over side BM in the right small triangle MBA. Repeat again. We derive that ST over AB equals to TM over BM. And also that side SM in the right middle triangle STM equals also to side SM in the right middle triangle STM over side AM in the right middle spot in the right middle triangle MBA. So in conclusion, we found out that ST over AB equals to TM over BM, and it is also equals to SM over AM. Side ST is the missing side, so we leave it as it is. ST over AB. AB is 2, therefore so AB by 2, and it is equals to TM over BM. TM, from the dominant, is very easy to see that TM equals to TB plus BM. That is to say, TM in total equals to TB, that is 2x, plus BM, that is 8 over 3. So in total, TM equals to 2x plus 8 over 3. So here, TM equals to 2x plus 8 over 3. So it is TM over BM. And so BM equals to 8 over 3. BM equals to 8 over 3. And it is also equals to SM over AM. SM in total equals to SA plus AM. That is to say, SM equals to SA, that is the missing side, plus AM, that is 10 over 3. So in total, SM equals to SA plus 10 over 3. Yeah. SM equals to SA plus 10 over 3 divided by AM. AM equals to 10 over 3. So in conclusion, we found out that ST over 2 equals to 2x plus 8 over 3 over 8 over 3, and it is also equals to SA plus 10 over 3 over 10 over 3. So those two sides are equal to each other, therefore we get equation 1 from those two sides that are equal to each other. So according to equation 1, ST over 2 equals to 2x plus 8 over 3 over 8 over 3. So according to equation 1, ST over 2 equals to, we have here 2x plus 8 over 3. So we multiply 2x by 3 and then we will divide it by 3 in order to come factor with 8 over 3. 2x times 3 is 6x, so in total in the numerator of this expression we have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. We focus on this side of equation 1. In this side of equation 1 we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. After we cancel 3, we left only with ST over 2, that is equals to 6x plus 8 divided by 8. So here we cross multiply this equation, equation 1, and we get that according to equation 1, 8 times ST equals to 2 times 6x plus 8. So here we divide this equation 1 by 2, and we get that 8 times 8 over 2 is 4, so in total in this side of the equation we have 4st. This equals to 2 over 2 is 1, so in this side of the equation we have to leave 6x plus 8. Here we divide this equation by 4, and finally we get that st equals to 6x over 4 is 1.5x plus 8 over 4 is 2. So in conclusion we found out that st equals to 2 plus 1.5x. So here this line segment st equals to 2 plus 1.5x. So I'll write it down here. St equals to 2 plus 1.5x. This line segment st, or side st, equals to 2 plus 1.5x. We will continue to focus on this long equation. We have here those two sides that are equal to each other, and those two expressions that are equal to each other. So we create equation 2 from those two expressions that are equal to each other. And according to equation 2, we will get that 2x plus 8 over 3 over 8 over 3 equals to SA plus 10 over 3 over 10 over 3. If we again according to equation 2, we found out that 2x plus 8 over 3 over 8 over 3 equals to SA plus 10 over 3 over 10 over 3. So in this side of equation 2 we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to overcome factor with 8 over 3. 2x times 3 is 6x. So in total, in the numerator of this expression, we will have 6x plus 8 divided by 3, and we have to divide it by 8 over 3. And it equals to SA plus 10 over 3. Here we multiply SA by 3, and then we divide it by 3 in order to overcome factor with 10 over 3. SA times 3 is 3SA, so in total, in the numerator of this expression, we will have 3SA plus 10 divided by 3, and we have to divide it also by 10 over 3. So in this side of equation 2, we have 3 in the numerator and 3 in the denominator, so 3 get cancelled. In the other side of the equation, we have also 3 in the numerator and 3 in the denominator, so 3 also get cancelled. After we cancel 3 on both sides of the equation, what is left of equation 2? In this side of equation 2, we left only with 6x plus 8 over 8. That equals, in the other side of the equation 2, we left only with 3SA plus 10 over 10. Here we cross multiply the equation 2, and we get that according to equation 2, 10 times 6x plus 8 equals to 8 times 3sa plus 10. So here we divide this equation 2 by 2, and we get that according to equation 2, 10 over 2 is 5, and inside the brackets we have 6x plus 8. That is equals to, here 8 over 2 is 4, and inside the brackets we have 3sa plus 10. So here we open the brackets on both sides of this equation 2, and we get that according to equation 2, 5 times 6x is 30x, plus 5 times 8 is 40, is equals to 4 times 3sa is 12sa, plus 4 times 10 is 40. So here we have 40 on both sides of the equation, so 40 will get cancelled. What is left for equation 2 after cancelled 40 on both sides of the equation? We left only, in this side of the equation, we left only 30x is equals to 12sa. So 30x equals to 12sa. Here we divide this equation 2 by 12, and we get that according to equation 2, SA equals to 30 over 12, again, we divided this equation by 2, and we get here, we divide this equation by 12, 30x equals to 12sa, so we divide this equation by 12, and we get that SA equals to 30x over 12, that is 2.5x. So if we're going to find out that SA equals to 2.5x, this line segment SA equals to 2.5x units in its length. In the next step, I will copy the small quadrilateral ASBT, this small quadrilateral, with the circle that is inscribed inside it, and we will implement on this quadrilateral rule 2. So this is the small quadrilateral ASBT with the circle that is described inside it that I copied from the original drawing. We define the point of tendency of tangent AS with this circle as K. We define the point of tendency of tangent AB with this circle as M. We define the point of tendency of tangent BT with this circle as H. And finally, we define the point of tendency of tangent SC with this circle as L. I repeat quickly on rule 2 and we will implement rule 2 in our drawing. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. So we have in the drawing a circle and the common standpoint point P. From the common standpoint point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. This is to say PA equals to PB. So we'll implement rule 2 in our drawing. We will focus on the common standpoint point A. From the common standpoint point A, we have two tangents to this circle, tangent AK and tangent AM. And according to rule 2, they are equal to each other. That is to say, AK equals to AM. So I write it down. Tangent AK equals to tangent AM in its length, according to rule 2. So if we define the length of tangent AK as A, then the length of tangent AM must be also equal to A because they are equal to each other. So in conclusion, we found out that AK equals to AM equals to A according to rule 2. In the next step, we will focus on this common external point, point B. For the common external point B, we have two tangents to this circle, tangent BM and tangent BH. And according to rule 2, they are equal to each other. That is to say, BM equals to BH. So I write it down. The length of tangent BM is equal to the length of tangent BH according to the same rule, rule 2. So if we define the length of tangent BM as B, then the length of tangent BH must be also equal to B because they are equal to each other. In conclusion, we found out that BM equals to BH equals to B. In the next step, we will focus on the common standpoint, point T. For the common external point C, we have two tangents to this circle, tangent T edge and tangent TL, and according to all two they are equal to each other. So I write it down. T edge equals to TL. The length of tangent T edge is equal to the length of tangent TL according to the same rule, rule 2. So if we define the length of tangent T edge as C, then the length of tangent TL must be also equal to C because they are equal to each other. So if we found out that TL equals to T edge equals to C. And finally, we focus on this common external point S. So for the common external point S, we have two tangents to this circle, tangent SK and tangent SL. And according to all two, they are equal to each other. That is to say, SK equals to SL. The length of tangent SK equals to the length of tangent SL. So if we define the length of tangent SK as D, then the length of tangent SL must be also equal to D because they are equal to each other. So if we found out that SK equals to SL equals to D according to the same rule, rule 2. In the next step, we will add side AB to the opposite side, side ST. Again, we will add side AB to side ST in this quadrilateral ASBT. So what is the value of AB plus ST? For the low it is very easy to see that AB plus ST equals to AB, that is A plus B, plus ST, that is C plus D. So in total, AB plus ST equals to A plus B plus C plus D. In the next step, we'll add side AS to the opposite side, side BT. So what is the value of AS plus BT? AS plus BT. From the drawing it is very easy to see that AS plus BT equals in total to A plus B plus C plus D. Again, AS plus BT in total equals to A plus B plus C plus D. So AS plus BT also equals to A plus B plus C plus D. So actually found out that those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. Okay? So actually found out that AB plus ST equals to AS plus BT. If it again, if we found out that AB plus ST equals to AS plus BT. Okay. So AB equals to 2 units in its length, therefore we substitute AB in this equation by 2. Plus ST. ST equals to 2 plus 1.5x, therefore we substitute ST by 2 plus 1.5x. And it is equals to AS plus BT. It is equals to AS plus BT. So AS, what is the value of AS? AS equals to 2.5x, therefore we substitute AS in this equation by 2.5x plus BT. BT equals to x plus x, that is 2x. Here, BT equals to 2x. So we substitute BT in this equation by 2x. So in conclusion, found out that 2 plus 2 plus 1.5x is equals to 2.5x plus 2x. 2 plus 2 is 4. So in total in this side of the equation we have 4 plus 1.5x. This equals to 2.5x plus 2x is 4.5x. So in conclusion, found out that 4 plus 1.5x equals to 4.5x. Here we subtract 1.5x from this equation, and we get that 4 equals to 4.5x minus 1.5x is 3x. So 4 equals to 3x. Here we divide this equation by 3. And finally we get that x equals to 4 over 3 units in its length. So the radius x of this circle is equal to 4 over 3 units in its length. The radius x equals to 4 over 3 units in its length. Again, our mission is to find out the area of this circle. We know that the formula for the area of any circle, is equals to pi times the radius of the circle squared. Therefore, the area of our circle will be equal to pi times the radius squared. The radius is x, therefore the radius squared is x squared. So the area of our circle is pi x squared. And we just right now found out that x equals to 4 over 3 units. So if x is 4 over 3, it means that x squared is 4 over 3 squared. So the area of our circle equals to pi times x squared, and x squared is 4 over 3 squared. So the area of our circle is is pi times 4 over 3 squared. So it is equals to pi, and 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So we found out that the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers it is equals to 5.585 square units. And that is the answer to the question. In the next step, I will summarize the lecture. In this lecture we found out the area of this circle. In the drawing we have a quadrilateral ABCD. Inside this quadrilateral we have this circle, In addition, we know that side AB equals to 2 units in its length, side BC equals to side CD, they are both equal to 8 units in its length. In addition, we know that this angle is angle ABC that is equal to 90 degrees, and this is also angle DCB, that is a right angle, this is equal to 90 degrees in its side. Again, our mission is to find out the area of this circle. In the first step, we did the construction, that is to say, we extended side DA and side CB of this quadrilateral by a straight line until they touch each other. So this is their touching point. We define their touching point as M. By doing this construction, we created the big right angle, triangle DCM. We define this angle as theta. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, this equals to 180 degrees. That is the sum of the angles in any triangle. Then focus on this segment CB. CB is one side of quadrilateral ABCD, therefore it is absolutely a straight line. Then extended the straight line CB by straight line, and extended straight line by straight line, the result must be a straight line. So CM must be a straight line also. So CM is a straight line, so if we focus on the upper side of this straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees plus the missing angle. In total must be equal to 180 degrees according to the rules that I mentioned. Therefore, the missing angle must be equal to 90 degrees. And therefore, triangle ABM is a right triangle. So in the right triangle ABM, the right small triangle ABM, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. Okay. Then we proved that the right big triangle DCM is similar to the right small triangle, triangle MBA. So why those two triangles are similar to each other? First of all, those two angles they are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that the angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we proved that all the three angles of the right triangle, the right big triangle DCM, are correspondingly equal to all the three angles of the right small triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side DC in the right big triangle DCM over side AB in the right small triangle MBA equals to side CM in the right big triangle DCM over side BM in the right small triangle MBA. So, I repeat again, we derive that DC over AB equals to CM over BM. DC is 8, AB is 2. What is the value of CM? From the law, it is very easy to see that CM equals to 8 plus BM. Again, CM equals to 8 plus BM. So it sums out CM here by 8 plus BM, and we have to divide it by BM. So in conclusion, we found out that 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4. So we found out actually that 4 equals to 8 plus BM over BM. Here we multiply this equation by BM and found out that 4 times BM equals to 8 plus BM. Here we subtract BM from this equation and found out that 4BM minus BM is 3BM, so 3BM equals to 8. Here we divided this equation by 3 and found out finally that BM equals to 8 over 3 since here this side BM equals to 8 over 3 since length. Then we implemented the Pythagoras theorem on this right triangle MBA. According to the Pythagoras theorem, in this right small triangle MBA, AM square equals to AB square plus BM square. Repeat again. In the right triangle MBA, AM square equals to AB square plus BM square. So AM square equals to AB square. AB is 2, therefore AB square is 2 squared, that is 4, plus BM square. BM is 8 over 3, therefore BM square is 8 over 3 squared, that is 64 over 9. So we should found out that AM square equals to 4 plus 64 over 9. Here we multiply 4 by 9 and then we divide it by 9 in order to return factor 64 over 9. 9 times 4 is 36. So in total, the numerator of this expression will have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. So AM square equals to 100 over 9. Here we took the order of this equation and finally found out that AM equals to the square root of 100 over 9. The square root of 100 over 9 is the square root of 100, that is 10, over the square root of 9, that is 3. So in conclusion, we found out that the length of the hypotenuse AM is 10 over 3 units. AM equals to 10 over 3 units. Then we did another construction, that is to say, we drew a perpendicular on BC in such a way that the perpendicular on BC will be also tangent to this circle. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular on BC as T. We define the point of tendency of the perpendicular with the circle as K. Then we extended the perpendicular TK by straight line until it touches side DA. We define the touching point of the extended perpendicular TK with side DA as point S. By doing this construction, we created the middle right triangle STM. In the middle right triangle STM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Then we define the center of this circle, this point as O, and we joined point O and then together by straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore N is the radius of this circle, that's equal to x according to our definition. We have the radius of N that is on to point N, therefore according to rule 1, whenever you have a radius that is on to the point of tendency, then tangent BT will be perpendicular to the radius NO. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Then we join points OL and M together by straight line. OL is the radius of this circle that is equal to x. The radius of OL is on to point L. Therefore, according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and K together by straight line. OK is the radius of this circle that is equal to x. The radius of K is drawn to point K, therefore according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. So inside this quadrangle OK and T, the small quadrangle OK and T, we have 1, 2, 3 angles, therefore the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So we can relate to this quadrangle OK and T as a rectangle because it has 4 right angles. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side OK equals to side NT. But OK equals to x, therefore NT must be also equal to x. Likewise, repeated on the same process in this small quadrangle LOBN. Inside this small quadrangle, we have 1, 2, 3 rectangles, therefore the fourth angle must be also equal to 90 degrees. So this quadrangle that has 4 rectangles, we can relate to it as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, side LO equals to side BN, but LO equals to x, therefore BN must be also equal to x. So in conclusion, found out that the length of line segment BT is x plus x, that is 2x. Here, BT equals to 2x units in its length. Okay, then we proved that the right middle triangle STM is similar to the right small triangle MBA. So why those two right angles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, this is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we prove that all the three angles of the right middle triangle STM are correspondingly equal to all the three angles of the right middle triangle MBA. Therefore, those two right angles are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that ST over AB equals to TM over BM equals to SM over AM. ST is the missing side, so we leave it as it is, over AB. AB is 2. And equals to TM over BM. What is the value of TM? From the drawing, it is very easy to see that TM equals to 2x plus 8 over 3. Okay, so here TM equals to 2x plus 8 over 3 over MB. MB is 8 over 3. Here BM is 8 over 3, and it is also equals to SM over AM. SM equals to S8, that is the missing side, plus AM, that is 10 over 3. So in total, SM equals to SA plus 10 over 3. Here, SM equals to SA plus 10 over 3 over AM. AM equals to 10 over 3. So if we're going to find out that ST over 2 equals to 2x plus 8 over 3 over 8 over 3, and it is also equals to SA plus 10 over 3 over 10 over 3. We have this long equation. We can do this long equation. In this long equation, those two sides are equal to each other, so we can get equation 1 from those two sides that are equal to each other. So according to equation number 1, ST over 2 equals to 2x plus 8 over 3 over 8 over 3. Okay? So ST over 2 equals to, here we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to work on a factor with 8 over 3. So 2x times 3 is 6x, so in total, in the numerator of this expression, we have 6x plus 8. 6x plus 8. And we have to divide it by 3, and we have also to divide it by 8 over 3. So in this of the question 1, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And we left only with ST over 2, that equals to 6x plus 8 over 8. Here, of course, multiply this equation 1, and found out actually that 8 times ST equals to 2 times 6x plus 8. Here we divided this equation 1 by 2, and finally found out that 8 over 2 is 4, so in total in this side of the equation we have 4st is equals to 2 over 2 is 1, so in this side of the equation we left only with 6x plus 8. So we found out that 4st equals to 6x plus 8. Here we divided this equation 1 by 4, and finally found out that st equals to 6x over 4 is 1.5x plus 8 over 2 is 2. So in conclusion, found out that st equals to 2 plus 1.5x. Here, this line segment st equals to 2 plus 1.5x. We continue to focus on the long equation. Those two sides that are equal to each other, therefore we get the equation 2 from those two sides that are equal to each other. So according to equation 2, 2x plus 8 over 3 over 8 over 3 equals to SA plus 8 over 3 over 8 over SA plus 10 over 3 over 10 over 3. So here we have 2x plus 8 over 3. So multiply 2x by 3 and then we divide it by 3 in order to come factor with 8 over 3. 2x times 3 is 6x. So in total, in the numerator of this expression, we have 6x plus 8 divided by 3, and we have to divide also by 8 over 3. In the other side of the equation, we have SA plus 10 over 3. Here we multiplied SA by 3, then we divided by 3 in order to overcome factor with 10 over 3. So 3 times SA is 3SA. So in total, the numerator of this expression will have 3SA plus 10 divided by 3, and we have to divide it by 10 over 3. Here we have 3 in the numerator, 3 in the denominator, so 3 will get cancelled. And on the other side of the equation, we have also 3 in the numerator, 3 in the denominator, so 3 will get cancelled. After we cancel 3 on both sides of the equation, we left only with 6x plus 8, that is equals to 3SA plus 10 over 10. Here we first multiply this equation 2, and found out that 10 times 6x plus 8 equals to 8 times 3SA plus 10. Here we divided the equation 2 by 2, and found out that 10 over 2 is 5, so inside the brackets we left only with 6x plus 8. On the other side of the equation we have 8 over 2, that is 4. Inside the brackets we have 3SA plus 10. Then we open the brackets on both sides of the equation and found out that 5 times 6x is 30x, plus 5 times 8 is 40. This equals to 4 times 3SA is 12SA, plus 4 times 10 is 40. So here we have 40 on both sides of the equation, so 40 will get cancelled, and we have only 30x, that is equals to 12SA. Here we divided this equation by 12 and finally found out that SA equals to 30x over 12 is 2.5x. So this line segment SA equals to 2.5x in its length. Then I complete the smooth quadrilateral ASBT in a new page with the circle that is inscribed inside it, and we implemented rule 2 in this quadrilateral with the circle that is inscribed inside it. This is actually quadrilateral ASBT that I copied from the original drawing with the circle that is inscribed inside it. Here we implemented rule 2. If we focus on the common standpoint point A, we have two tangents to this circle, tangent AK and tangent AM. And according to rule 2, they are equal to each other. That is to say, AK equals to AM. AK equals to AM. So if we define the length of AK as A, then the length of AM must be also equal to A, because they are equal to each other. So in conclusion, we found out that AK equals to AM equals to A. Then we focus on the common standpoint point B. From the common standpoint point B, we have two tangents to this again, tangent BM and tangent BH. And according to rule 2, they are equal to each other. So BM equals to BH. So if we define BM as B, then BH must be also equal to B. So BM equals to BH equals to B. Then we focus on the common standpoint point T. For the common standpoint point T, we have two tangents to this again, tangent TL and tangent TH. And according to rule 2, they are equal to each other. That is to say, TH equals to TL. So if we define the length of TL as C, then TH must be also equal to C because they are equal to each other. So in conclusion, we found out that TH equals to TL equals to C. And finally, we focus on the common standpoint point S. From the common standpoint point S, we have two tangents to this circle, tangent SK and tangent SN. And tangent SN. And according to rule 2, they are equal to each other. That is to say, SK equals to SL. So if we define the length of SK as D, then SL must be also equal to D because they are equal to each other. So in conclusion, we found out that SK equals to SL equals to D. Then we join side AB to side ST. AB plus ST, in total it is equal to A plus B plus C plus D. In the next step, we join the side AS to the opposite side BT. AS plus BT, it is also equal to A plus B plus C plus D. So those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. That is to say, we found out actually that AS plus BT, that AB plus ST equals to AS plus BT. AB is 2 plus ST. ST is 2 plus 1.5x. So we substitute ST by 2 plus 1.5x, and it is equal to AS. AS is 2.5x, therefore substitute AS by 2.5x plus BT. Here, BT is 2x, so we substitute BT by 2x. So in conclusion, found out that 2 plus 2 plus 1.5x equals to 2.5x plus 2x. 2 plus 2 is 4, so in total this side of the in this side of the equation we have 2 plus 2 is 4, so in total this side of the equation we have 4 plus 1.5x. That equals to 2.5x plus 2x is 4.5x. So in total found out that 4 plus 1.5x equals to 4.5x. Here we subtract 1.5x from this equation and finally found out that 4 equals to 4.5x minus 1.5x is 3x. So 4 equals to 3x. Here we divided this equation by 3 and finally found out that x equals to 4 over 3 units instead. That is to say, the radius x of this circle equals to 4 over 3 units instead. Our mission is to find out the area of this circle. The area of any circle equals to pi times the radius of the circle squared. Therefore, the area of our circle will be equal to pi times the radius squared. The radius is x, therefore the radius squared is x squared. So the area of our circle is pi times x squared, and we just right now found out that x equals to 4 over 3. If x is 4 over 3, it means that x squared is 4 over 3 squared. Therefore, pi x squared is pi times 4 over 3 squared. So the area of our circle equals to pi, and 4 over 3 squared is 4 squared, that is 16, over 3 squared, that is 9. So in total found out actually that the area of our circle equals to either 16 pi over 9 square units, or in terms of numbers, the area of this circle equals to 5.585 square units. Okay, thank you very much.